So, welcome to the next video in the series. Now we're going to be talking about vector and scalar projections. So these sound really intimidating, but they're actually not that hard. They are derived from this equation, actually, the one that we talked about in the last video, which is magnitude of A times the magnitude of B times cosine theta is equal to the dot product of A and B, or vectors A and vectors B. So how do you find the scalar projection? Well, we're going to start with the scalar projection. What exactly the scalar projection is, I still can't explain very well, but I'm going to explain how this equation works. So, how is it? Well, all you have to do is first rewrite the equation. So the original equation that I'm getting that one from is cosine theta is equal to A dot product of B over magnitude of A magnitude of B. Let's pretend that's our starting point. But my point is, if you want to project one onto the other, all you have to do is move the one that you are projecting off to the other side. Actually, let me verify it's not the other one. Yeah, you just remove the one that you're projecting onto the other to the other side of the equation. So let's say we want to take A and project it onto B. Projected onto B. So what do? We just take a B, actually I'm going to change coloring, B right here, and we move it to the other side. We get magnitude B cosine theta is equal to A dot B over magnitude of A. That's literally it. So if you want the scalar projection of one onto the other, the result of either of the sides of this is your scalar projection. That's essentially the length of one vector on another. So like if I have this vector, we're going to hope and pray that I explain this correctly. If I have this vector, and I also have this vector, how far would this vector go along this vector? I'm actually going to make the different colors so it makes more sense. Okay. So I have this vector. How long would this vector go along this vector? I don't know, probably about that far. That's your scalar projection. How that works mathematically, don't ask me. I don't know. I'm still figuring that out. That's why I'm here. Probably why you're here too. But that's what the scalar projection is. Now, what is the vector projection? The vector projection is just another step in manipulating these. So you take this answer. Let me use this side because I like this one because it's simple. And you're going to multiply that as a scalar multiplier, because remember a scalar is like it scales it up, times a vector. Not dot product, like this is, we're actually scaling a vector. And it's not just any vector, it's the vector that you're projecting onto. And don't check those notes. You are projecting it just, so if you're projecting A onto B, then it is that onto the unit vector of B. Okay, so it's not just the vector, it's the unit vector of B, which makes sense because you're using cosine here and you're scaling it down. So you have to be in a unit so you can essentially scale your vector by the vector that you just scaled from, if that makes no sense. So let's pretend that the unit vector of A is, for simplicity's sake, 1, 3. That's not a unit vector, but pretend it's like that. So you take the unit vector, and I'm going to pretend that B cosine theta comes out to be 1. So you multiply, actually, let's make that 2. 2 times 1, 3. And if you remember back to like my first video, this is literally just scaling a vector. 2, 6. And now you have your vector projection. So I hope that explains how to actually perform your scalar and vector projections. Let's review. You project A onto B, you just remove the one that you are projecting onto to the other side. Actually. Yeah. A onto B. Yeah. So you project the one that you're projecting onto the other, you move out, and then that's your scalar projection, and the vector projection is going to be um, the one that you're doing it onto being the vector, the unit vector would be multiplied by the scalar projection of whatever else you're doing. Because I feel like you can mix and match those where like do a scalar projection of B onto A and then a vector projection of that of A onto B. Actually, I don't think that would work because it goes in tiers. Yeah, so yeah, that makes sense. You go in tiers, and if you built on the wrong one, then you can't do another projection because it won't work out because you're on the wrong base. I think. But yeah, I hope that makes sense and that you can actually see the whiteboard. Thanks.